Hello students, in this video I am starting new chapter Algebra. This algebra, it is one of the important branch of mathematics. Algebra is very helpful to solve riddles, puzzles and also so many problems what you are facing in our daily life. From primary section we are solving problems on arithmetic operations, some geometrical figures, all those are including in this algebra. Mainly algebra means it is the combination of constants and variables. If we join some constants and variables, we will get terms. If we join these terms by using either plus symbol or minus symbol, we will get expressions. The expressions which are made by using constants and variables, they are said to be algebraic expressions. From 6th class onwards, we are having the chapter algebraic expressions. See, if we get some knowledge on basics of algebra, the chapter is very simple to understand. That's why in the first video, I am going to give full clarification on basics of algebra. First of all, we will learn about constants. See, what are constants? Everybody knows numbers. Okay, numbers means these are fixed values. Fixed values. It means they never change. Suppose 1. 1 means always it is 1. 2, 3, 100, 1 by 7, 2.5. All these are numbers and also fixed values. 5 means it is always 5, 3 means always 3. Okay? So such numbers are said to be constants. These individually we will tell terms. And also these numbers also called as numerals. So each individual number is said to be numerical term. Means this is one numerical term, this is also another numerical term, this one is different numerical term. If we join these numerical terms by using either plus symbol or minus symbol, they are said to be numerical expressions. See, suppose 2 plus 5, we know the answer is 7, but this is the expression. 2 plus 5 is expression, and also we are using only numbers. This is said to be numerical expression. Okay, see, actually this numerical expression we can write as the statement also. 5 is added to 2 or 2 is added to 5. That is the statement. The statement we are using here by constant numbers. This is said to be expression. Only numbers it is. Okay, here only numbers we are using. That's why it is said to be numerical expression. Numerical expression. In numerical expression, we will use only numbers. Okay, here two terms are there. Two terms separated by plus symbol. Suppose if I write 10 minus 3, here also we are using two numbers and also two terms differentiated by minus symbol. This is said to be numerical expression. This we can write as statement also. 10 decreased by 3. 3 removed from 10. Like that statement we can write. That statement changes as expression. And here we are using only constants. That's why this is said to be numerical expression. For this, if we add plus 25, here three terms are there. Here minus symbol, here plus symbol. Again I will write plus 42 minus 36. See, here how many terms are there? 1, 2, 3, 4, 5 terms are there. All these are only numbers which are constant values. Okay, so this is said to be numerical expression. Okay, all are numerical terms. That's why it is said to be numerical expressions. Now I will write by using multiplication and division symbols. What will happen? See, first one I am writing 15 into 3. 15 3 is 45. This is single term. Two numbers are there, but we are using multiplication symbol. If numbers are separated by either plus symbol or minus symbol, then only we will say they are different terms. Okay, here 15 into 3 we are using multiplication symbol. That's why this is single term. Okay, plus I am going to write second term. Here suppose 20 by 3. 20 by 3, this is also single term. Okay, 20 by 3 we are using division symbol. That's why this one is only one term. Now minus 14 into 5 by 7. Okay, 14 into 5 by 7. We are using multiplication symbol and division symbol. These three numbers belongs to single term. So totally how many terms here? This is the first term, this is the second term, this one is third term. Here we are using only numbers. There is no letter, there is no variable. All are numbers. That means numerals. That's why these are said to be numerical term. This one, this one, this one. And this combinedly we will say it is numerical expression. Numerical expression formed by using only numbers or numerals. Okay. Now I think you get complete idea on constants. If we use constants, that means fixed values, we will get numerical expressions. Now our topic is algebraic expressions. We will go to that topic. For that we have to know about variables. Variables. What are variables? Constants means fixed values. Variable means unknown values. Unknown values. Unknown values, or we can say not fixed values. These are not fixed values. These values change for problem to problem. These are unknown quantities, unknown values. Then what numbers we are going to use? Here we are using numbers. Constants we are using numbers. But for variables we are using English alphabets like A, B, C, X, Y, Z, P, Q, like that we will use. Okay? What is A? What is B? We don't know these values. Okay? Only for unknown quantities we are using this. In particular problem, A we will take 10 centimeters. In other place we will take A 4 kilometers. In some cases we will take A 100 rupees. Means problem to problem it will change. That is said to be variable. Okay. Suppose you see this is the square. Okay. In this square we will write side as yes. I am taking here yes. Okay. Somebody will take as A. Somebody will take as X. Now here I am using side as S. All sides are equal in this side. Okay, square, all sides are equal. So that is S, this one also S, here also S, here also S. We want to find the perimeter. You know what is the problem of perimeter? Perimeter equal to 4 sides. 4 into sides. That is what? 4 into, here side represented by S. 4 into S. Sometimes simply we will write this as 4S. Okay. See, what is S here? S is the variable. We don't know that value. If anybody given side equal to 10 centimeters, then 10, 10, 10, 10, like that 40. Here we will get directly 4 into 10 centimeters. This will be formula of perimeter of the square. If we use the symbol here, it is very easy to solve the problem. Always it is difficult to add 15 plus 15 plus 15 plus 15, it is 60. Instead of that 15 4 ja, directly we can say it is 60. That implies here S is unknown quantity. Okay, that is said to be variable. If we use such variables, this is said to be literal term. What we say it is literal term. We are using letters. Here we are using letters. Here we are using numbers. Okay. Remember this point. Constants means we are using numbers and variables means we are using letters. That's why these are said to be numerical terms and these are said to be literal terms. For us it is literal term. Now I am writing one point. Suppose 2a plus 5. See, this is also, first one is, here a is variable, 2 we know that is number. But 2a it is also again variable. It means this one 2a is literal term. Okay. But 5 it is constant term. We are using both here. 2a plus 5. Totally 2 terms here because plus is there. Okay, total 2 terms. We will say this one as literal expression. Okay, only numbers means numerical expression, but letters are there. That is said to be literal expression. That is also said to be algebraic expression. Okay, literal expression is also said to be algebraic expression. Only 2 terms are there. Now, see this. One more I will give example. This is the triangle. This ABC. I will put the names ABC. In this triangle, suppose this length I will give here small a. I don't know that actual length. B opposite I will put small b length. C opposite I am putting small c. Now what is this perimeter of this triangle? We have to add 3 sides. Okay? We have to add 3 sides. Here A plus B plus C. These 3 values not mentioned here. Okay? It means the variables. You can write any values here. Sum of 3 sides, it is perimeter of the triangle. But here we are using 3 letters. These are literal terms. Okay. Totally we will say this is algebraic expression. This one is algebraic expression. See, here 2 terms, here 3 terms. In this 1, 2, 3, 4, 5 terms. Here only 2 terms. Like that we have to find number of terms. Depending upon number of terms also, we are having different names. If single term monomial, 2 terms binomial, 3 terms trinomial, like that. We will discuss the topic later. We will discuss some more about these terms. Right. Students, I explained about constants and variables. Constants means numbers, they are fixed values. And variables means letters, they are unknown quantities. Okay. Now we will learn about coefficients. What is the meaning of coefficient? See, we will take one example 2xy. Here 2 into x into y. 2 is constant number, x and y are variables. Okay. 2xy, this is one algebraic term, only single term. Here xy is multiplying by 2. So that's why 2 is said to be coefficient of xy. And also 2 is number. It means numeral. So we can say 2 is what? Numerical coefficient. Numerical coefficient of xy. Okay. They will ask what is the coefficient of xy generally. You have to say 2 is coefficient of xy. It is the number, that's why what we are telling it is numerical coefficient. If suppose they will ask what is the coefficient of 2? What is coefficient of 2? It means which is multiplying by 2? xy. Okay. So what is xy? xy is said to be, this is numerical coefficient, number, but this is literal term, so that is literal coefficient. Literal coefficient. See, suppose if 24 is there, we can write 24 as 3 into 8. Okay, 3 and 8 are factors of 24. Like that we are telling. 2 into 12. 2 and 12 are also factors of 24. Like that, 2xy we can write as 2 into x into y. Okay. So, 2 is coefficient of xy. xy is coefficient of 2. Then if they ask, what is the coefficient of 2x? You just close the 2x. What is appearing? Y. Okay. Y is coefficient of 2x. Suppose what is the coefficient of 2y? You close this 2y. Appearing only x. So, coefficient of 2y is what? X. Like that we have to say. Now, I will write one more. 2a plus 3b minus 5c. Okay. Here we are using variables a, b, c. 3 terms are there. What is the coefficient of a here? 2. Coefficient of b is what? 3. Coefficient of c is what? Don't say 5. minus 5 we will say. Okay, coefficient of C is what? Minus 5. Now I will write another one. 3x square y. Here 3 is numerical term, x and y are variables. Okay, 3x square y. This is single term. Here, what is the coefficient of x square y? 3. Coefficient of x square y is 3. What is the coefficient of 3? X square y. What is the coefficient of 3y? X square. Now coefficient of x square is what? 3y. Like that we have to say. And one more, see carefully. 3x square means 3 into x into x into y. Then if they ask what is the coefficient of x here, so you just close one x. 3xy you have to say. Coefficient of x is what here? 3xy. Suppose if minus symbol is there, minus 3x square y. If they ask what is the coefficient of x square y, you have to say minus 3. What is the coefficient of minus 3? X square y. What is the coefficient of only 3? Minus x square y. What is the coefficient of y here? Minus 3x square. Now I will explain next topic. Like terms, unlike terms. What are like terms? What are unlike terms? See, here I have given some algebraic terms. 12x, 25y, minus 3x, minus 7y, 4z, 2xy, 14 and 3xy. Here, this 14, it is only number. So this is numerical term. And the remaining others are algebraic terms. Okay. Here, 12x. Literal coefficient is x here. Literal coefficient, numerical coefficient 12. Literal coefficient x. Observe here. Is there any term like that? Here minus 3x is there. X is literal coefficient. Only 2. So, like terms here 12x and minus 3x. Okay. These two are like terms. Similarly here 25y. Is there any other term like having y as literal term? Here minus 7y. So 25y and minus 7y. Okay. These two are like terms. Now here 4z. Is there any term like that? No. So we will write here unlike term. 2xy. Here 3xy. Here xy literal coefficient. Here also xy literal coefficient. So these two we can write as like terms. 2xy, 3xy like terms. Okay. Now 14, there is no other number like that. Okay. We will write here. These two are like terms. Unlike terms, like terms. Okay. So the terms containing having same numerical coefficient. Here x and x both are having same coefficient, literal coefficient that is. Okay. So we can write them as like terms. I will write one more example. See, suppose 5x square 12xz minus 13x square 4x. You see here. In this, like terms, unlike terms, we will write 5x square. Is there any term like that? Observe here, minus 13x square. These two like terms. So 5x square and minus 13x square. These two like terms. Now 12xz, is there any term like that? Here 4x, these two different. So we can write 12xz and that 4x. Okay, 12xz and 4x. These two unlike terms. Okay, so different literal coefficient. Here xz, here x. So they are different literal coefficients. So unlike terms. Right? I think you understand. Like terms, unlike terms. If the literal coefficients are same, here x means here only, here also x we have to see. And suppose if there are 3x square y, 5x y square, 7x square y. Observe here. 3x square y, 7x square y. These two like terms. This is xy square. Different one. Unlike term it is. xy square. Here x square y. You have to remember that point. And one more. Suppose 7xy, 2xz, 5yx, 2zx. Observe here. Like terms we will see. Here 7xy. Is there any term like that? If you see here 5yx, both are like terms. Xy is nothing but yx. In arithmetic, what we are doing? 3 into 4 is 4 into 3, both are same. Okay? This is said to be commutative law. Like that here also, x into y is y into x, both are same. So 7xy and 5xy, these two one category, like terms. Okay? Now, these two, this is 2xz, this is 2zx. Both are like terms. Okay? Zx, xz, both will be same. So these two like terms, these two like terms. So remember that thing. And in the next video, I will give explanation of some other basic terms. Right? If you like my video, please share, comment, and also subscribe the channel to watch the next videos. Thank you.